In this video, we will be discussing the Let's Learn the Basics section on page 81 of the SHIN-CHU-MON, Mathematics for 8th grade. This section contains a problem about filling a water tank using two pipes. In this problem, we will be using our knowledge of linear functions to answer three questions about the filling of the tank. Now, let's begin by reading the problem. Figure 1 shows a cuboid-shaped tank that is 68 centimeters deep. Suppose this tank is filled with water by using pipes A and B together for the first 12 minutes, and then after that, pipe B only until the tank is completely full. Figure 2 shows a graph of the relationship between x, the elapsed time in minutes measured from when the filling begins, and y, the depth of the water in the tank. So let's have a closer look at these figures. On the left, we have figure 1, which shows us the cuboid-shaped tank, and we also see we have pipe A and pipe B. And on the right side, we have a graph which shows the relationship between x and y. And in this case, x is the elapsed time in minutes, so we can show that here. And elapsed time means the amount of time that passes since something has happened. And in this case, it's since the filling of the tank begins. And y in this case is the depth of the water in the tank. So we can also label that here, the depth of the water, and the units are centimeters in this case. Okay, so the problem tells us at time 0, we turn on both pipes. So we have pipe A and B, and water is coming out. And as the water goes into the tank slowly begins to fill. So we can show that here. And as time goes by, the depth of the water increases. And then we see that after 12 minutes, we get to this point on our graph. And that tells us that the depth of the water reaches 48 centimeters. So we can show that here on our drawing, 48 centimeters. And let's see, that looks like this. So the red line shows us the depth of the water after 12 minutes. So what happens next? Well, the problem says that we turn off pipe A and we continue to use pipe B, and as pipe B flows, the depth of the water continues to increase, but at a slower rate than before. But eventually, the tank will fill, and the depth of the water will become 68 centimeters. So we show that here on the graph. So it becomes 68 centimeters after 20 minutes. And one other thing we should note on our graph is, once again, that this first section between 0 and 12 is when we're using pipes A and B together. So notice the slope of the line. That's the slope of the line during that part of the graph. And then from 12 to 20 minutes, we're only using pipe B. And we also have a straight line, but the slope is not as great. So the depth increases, but at a slower rate during that period of time. Now let's look at the first question. Question 1 asks, when x is greater than or equal to 12 and less than or equal to 20, express y in terms of x. So this question asks us about the period when x is greater than or equal to 12 and less than or equal to 20. And that's referring to this portion of the graph. Notice that this is between the points 12, 48, and 20, 68. And since this is a straight line, we know that it's a linear expression. And the general form of a linear expression is y equals ax plus b. And you may recall that x refers to the slope of the line, and b is the y-intercept. So we need to find both a and b in order to solve this problem. So first, let's focus on slope. Slope is rise over run, which is another way of saying the change in y over the change in x. So looking at our graph, we can see the change in y is between 48 and 68. So this is called the rise, or delta y. And the run is the change in x between 12 and 20. So we can show that here. This is the run, which is delta x. So we can rewrite that as slope equals delta y over delta x, which is 68 minus 48 over 20 minus 12, which is 20 over 8, which then simplifies to 2.5. So that's the value of a in this case. Next, we need to find b. Now you recall that I mentioned that b is called the y-intercept. So what that means is if we were to draw a straight line, extend that graph all the way to the y-axis, we would intercept the y-axis at this point. And that is the y-intercept. So we need to find that value in this case. The way we can do that is simply substitute the values of x and y at this point. We'll just choose that point, 1248. So to find b, substitute the values of x and y for the point 1248. When we do that, we have 48 equals a, which in this case is 2.5, times x, which is 12, plus b. We can then rewrite it as b equals 48 minus 30, which equals 18. Therefore, the answer to 1 is y equals 2.5 x plus 18. Question 2 asks us, how many minutes after filling began did the water depth become 53 centimeters? So, looking at our graph, we see that when the depth is 53, that corresponds to this point on the graph. And if we look at the x value in that case, it would be somewhere here. Since this is in the period between x equal or greater than 12 and x less than or equal to 20, the expression that we found in part 1, this expression, applies. So what we need to do to solve part 2 is to substitute y equals 53 into the expression in 1. And that expression was y equals 2.5x plus 18. So when y is 53, we can write 53 equals 2.5x plus 18. Solving for x, we get 2.5x equals 35. X equals 35 divided by 2.5, which equals 14. So we can write the answer as 14 minutes after the filling begins, the depth of the water becomes 53 centimeters. So the answer is 14 minutes. In question 3, it asks, if only pipe A is used, how many centimeters per minute will the depth of the water increase? According to the graph, the rate of increase when pipes A and B are used together is the slope of this line. And as you may remember, slope equals rise over run, which is another way of saying the change in y over the change in x. So in this case, the change in y is this, which is 48, and the change in x is this, which is 12. So that is 4 centimeters per minute. That's the rate of change when pipes A and B are used together. And you might remember from part 1 that when B is used by itself, the rate of change was 2.5 centimeters per minute. Therefore, to answer part 3, we have to take 4 centimeters per minute and subtract 2.5 centimeters per minute, and that gives us 1.5 centimeters per minute, which is if only pipe A is used. And that's the answer to part 3.